The first thing you need to do, guys, is to put the angle in radians. So you press the equal sign, and click the angle times pi. You can put 3.14, but divide by 180, but that pi does not have 2 decimal places 14. It has an infinity amount of decimal places, so it's more precise if you do pi parenthesis, and pi parenthesis is going to calculate pi with many decimal places. Let me do it over here so you can see. So if you put pi parenthesis, you have pi with many decimal places. All right, so then you click it and drag it, and those are your angles in radians. The velocity at the top, you let it go, you release it. So the initial velocity is 0 at the top. And the height, I explained it to you. The height is 1. The length is 1 minus cosine of the angle. Make sure you click the 1 in radians. And that is the height at which you let it go if the length is 1. Okay? And those are the heights. Then the kinetic energy is 0 because the initial velocity is 0. So the initial kinetic energy is 0 because it's 1/2 mass times the square of the velocity. And the potential energy is the mass, that is 1 kilo, times 9.8, the acceleration of gravity, times the height. And these are the potential energy. And mechanical, as I said, is the sum, but because the kinetic is 0, the mechanical is just potential. So it's kinetic plus potential. And because the kinetic is 0, the mechanical energy at the top position, at the release position, is potential energy. Okay, now let's do the calculations at the bottom. The velocity, as I show you in the derivation that I show you in the document camera, is going to be in a separate video. The velocity is 2 times pi times the angle in radians times the length, which is 1, divided by the period, and those are the velocities at the bottom of the trajectory. Those are the velocities at the bottom of the trajectory. The final height is 0 because we set up the reference point, the 0, at the bottom of the trajectory. And the kinetic energy is not 0 because it's 1/2, close the parenthesis, times the mass, that is 1 kilo, times the velocity squared. And these are the velocity, the kinetic energy at the bottom of the trajectory. The potentials are 0 because the height are 0. We set up the 0 over there. And the sum is kinetic because the potential is 0. So it's kinetic plus potential. I'm doing it like this because we are going to do this experiment in real life, not using the simulation. And we are going to do exactly the same calculations that you are seeing now, but with real data. Okay, so this is the expectation. This is how you do the calculations. And now I want you to do the graph. The graph is going to be H and M. That's why you need to do the graph. Mechanical energy initial in the horizontal axis, mechanical energy final in the vertical axis. Okay, that's what we are going to do now. As you see, I go up to column 20, from row 3 to row 20. So I'll click a blank cell, insert, chart. I hope it didn't put any data. If Cheat puts some data over here, please try to click a cell away from the data. So choose the scatter plot like always. And in the horizontal axis, you are going to put mechanical energy initial. That is age 3, semicolon, age 20, comma. Mechanical energy final is, let me see over here, M. So M3, semicolon, M20. And as you can see, it's a straight line. And in theory, they are supposed to be equal. That means that potential energy at the top transformed into kinetic energy at the bottom. So in theory, the slope of this line is supposed to be 1. So now we go to customize, axis title. I won't put a title. The vertical axis is mechanical energy. Final is equal to kinetic energy final plus 0. Okay, I will put it like that, and yes, this is going to be in joules. Joules is the unit of energy. Let's put it like that. In the horizontal axis is mechanical energy initial, which is 0 kinetic plus potential energy initial, and this is in joules. I want you to do it like that. All right, now let's put a trend line. I like the points to be black and 4, but that's not required. Trend line, positive 80, and label use equation, and the slope supposed to be 1, and I got 0.899, okay, which is very close to 1. The reason is not exactly 1 because this is a simulation. You're supposed to tell me how come this is a simulation. We are supposed to get 1 over here because this is simulated data. The reason is that the velocity of the button, that equation that we use to calculate BF, is an approximation. It's not the exact formula to calculate the velocity at the bottom. When we do the experiment, you are going to see that maybe the experiment, because in the experiment we measure the velocity at the bottom, we are going to see a better result than the simulation. All right, so that's it. Let me increase the font over here. No, it didn't. Okay, so this is the expectation. So the table is now complete and the graph is now complete. I can go now, move down and put the graph over here at the bottom of the chart. See that? So that's the expectation for today, is to have the table and the graph complete. If you need help, please let me know.